Hello everyone. Uh, I'm going to introduce you with a very renowned and very useful software called STAAD Pro, which is mainly used for design and analysis of steel and concrete structures around the world in many projects, in big projects, small projects, on a personal level, on commercial level. So it is a very popular and widely used software. Uh, so what is STAAD Pro actually? I just said that it is a structural engineering software which allows engineers like us or architects like us or students like us to analyze and design a variety of structures, including buildings, bridges, industrial plants, or any kind of a structure which needs design and analysis. So with STAAD Pro, engineers can perform complex analysis, optimize designs, and ensure the safety and reliability of their structures. It offers a wide range of analysis and design capabilities, including static and dynamic analysis, finite element analysis, and seismic analysis. So the software has a very user-friendly interface that allows engineers to easily model and analyze structures, as well as view and interpret results. STAAD Pro also includes design and optimization tools that help engineers create efficient and cost-effective structures. So we'll talk about the features and capabilities of the STAAD Pro software. So the main capabilities are like it is used for structural analysis and design. It provides a comprehensive structural analysis and design capabilities for a wide range of structures, including buildings, bridges, towers, and industrial structures. It also allows users to model and analyze complex structural systems using advanced finite element analysis techniques. STAAD Pro offers a multi-material design. It means that it allows users to model and analyze structures made of different materials such as steel, concrete, timber, aluminum, if any other kind of material you can define, giving its properties in the software, you can use that as well. Even you can design glass structures as well in STAAD Pro. So it provides tools for designing and optimizing each material type based on its unique properties and behavior under the different loads and conditions. While talking about dynamic analysis, STAAD Pro includes advanced dynamic analysis capabilities for modeling and analyzing structures subjected to dynamic loads such as earthquake, wind, vibration, even fatigue. For fatigue, you can design for shock-related designs where there is an ultimate amount of load with very fraction time, means even fraction of seconds. For example, a blast. So when you're designing an equipment or a structure which should be safe for shock loads, so StatPro also offers that thing. Uh, it allows users to stimulate the behavior of structures under different dynamic conditions and optimize their design to ensure safety and performance. Uh, the user interface. So STAAD Pro provides a very user-friendly and very easy to use and easy to understand uh, many properties in its interface. So a college student or a professional or anyone can use it without any hassle. So it does not take it very much efforts in learning this software because it is a very user-friendly software. So STAAD Pro offers uh, uh, a very simple and unique user interface, and it is designed to be intuitive and user-friendly, allowing engineers and designers to quickly and easily access the software's powerful features and capabilities. The interface is customizable with options to adjust the layout and toolbars to suit individual preferences and workflows. Graphical user interface for visualizing and manipulating models, customizable toolbars and menus for streamlined workflows, context-sensitive help and documentation for easy reference and troubleshooting. Yeah. So if you need any help, so you don't need to go out. There is a help section within the software itself where you can search any kind of thing which you are like searching for, and any feature you're not finding within the software. So in the help section, you can search it and you can find it within the software itself. You don't have to go out to search on Google or somewhere else. And also, you can generate the report from the software itself. So if you would like to save your time and you have your model and you don't want to work in MS Word and create a separate document, so STAAD Pro also offers you for the documentation to save your time and save your energy so that you can meet your schedules and meet the deadlines as prescribed. While talking about the modeling analysis, STAAD Pro provides a wide range of modeling tools that enable users to create accurate and detailed 3D models of structures, including buildings, bridges, and towers. These tools include automatic mesh generation, which simplifies the process of creating finite element models, as well as the ability to import and export models from other software packages. STAAD Pro also allows for the creation of complex geometries such as curved surfaces and tapered members, and includes a library of standard section and materials to streamline the modeling process. STAAD Pro includes many different sections. Means if you want to design a structure based on we say British sections or European section, Indian sections, Korean section, Chinese section, Russian sections, American sections. So STAAD Pro library is very huge, very huge. Uh, Talking about analysis, STAAD Pro offers a range of advanced analysis capabilities, including linear and non-linear, static and dynamic analysis, time history analysis, and response spectrum analysis. The software also includes a variety of load types such as wind, seismic, and temperature loads, and allows for the creation of custom load cases to simulate specific scenarios. It also creates load combinations by itself. Users can also perform design checks to ensure that their structures meet industry standards and codes and optimize their design to reduce material usage and cost. So yeah, while talking about codes, STAAD Pro provides many mm, codes such as you can design your structure based on American code, you can design your structure based on European code, you can design your structure based on Indian code as well. So there are some few renowned examples where STAAD Pro has been used. So in bridge design, STAAD Pro was used in the design of the new Golden Gate Bridge in San Francisco. So it is one of the best example of engineering marvel around the world. One of the longest suspension bridge, and STAAD Pro was used for the analysis and design of this bridge. This software helped the engineers model and analyze complex forces acting on the bridge, ensuring its stability and safety. Another very famous example for high-rise building design is Burj Khalifa. Yes, so STAAD Pro was also used in the design of Burj Khalifa, the tallest building in the world. The software helped engineers model and analyze the complex forces acting on the building, ensuring its stability and safety. Yeah, one of the main reasons to use the design software is ensuring the stability and safety of any structure. And the best and one of the widely used application of STAAD Pro is in industrial plant designs. So most of the steel structures around the world, such as in oil and gas refinery, energy and chemical plants, steam generation plants, STAAD Pro is widely used. The software helps engineer model analyze the complex forces and ensure its safety and efficiency. Now, we will perform a design on STAAD Pro and we will compare it with our hand calculation. So we will analyze a simply supported beam using STAAD Pro and we will compare it with the hand calculation. So for this, let's say we have a beam, we have a steel beam whose length is 5 meter and it is simply supported at both the ends, and we are applying a 50 kilonewton concentrated point load at the center of the beam. So when we calculate the reactions at the end, we find that what are the reactions? The reactions are P by 2. So if you are applying 50 kilonewton at the center of the simply supported beam, it will be equally distributed at the ends, and the reactions will be 50 by 2, 25 kilonewton at A end, and at the B end, it will be same 25 kilonewton. The maximum moment at center will be RA into L by 2, and RA is equal to P by 2. So P by 2 into L by 2 is PL by 4. So the maximum moment at the center will be P into L by 4, which gives us 62.5 kilonewton meter moment at the center. And if we see, we have already studied, this is the very basic thing which we study in engineering mechanics and design of structures. The shear force diagram of a simply supported beam with point load is this, and the moment diagram is this, where the maximum moment is at the center, values PL by 4. So let's open STAAD Pro. STAAD. So I have the STAAD Pro V8i version, and I'm going to start a new project. Let's name it beam design. Okay, so length units I'm selecting in meter and force units in kilonewton. Clicking on next, add beam, okay, finish. So here we start the software, and this is the first page or the interface page when you open any STAAD Pro software, any version it is. So we will just turn off this snap node function. So we have a blank sheet in which we will first model the geometry. So we have a beam length which is 5 meter, and we have applied 50 kilonewton load in the center, and we have provided two supports at ends, and both the supports are simply supported, means there will be no moment at the ends. So let's model. So first thing is we will go to setup. We will name the file name or anything we would like to let the job is beam design. Okay. Let's go to geometry. Turn off this snap node beam. Now click on the node, put it 0. So yeah, as you can see this black dot, we have created a node in this space at 0, 0, 0. So this will be our center. Now, since the length of the beam is 5 meter, we will provide x distance as 5 meter, another as 0, 0. So we have two nodes. Now we will create beam. So this is the function of add beams. So just click on it and go from left to right. So we have joined this. As you can see, we have successfully created a beam in STAAD Pro. When we will press Shift plus N, it will show us the node number. So I've just created two nodes, node 1 and node 2, and these are the coordinates 0, 0, 0 and 5, 0, 0. And we have created a beam. If you will press Shift plus B, then it will show the beam number. So the beam number, since there is only one beam, so the beam number is 1. I said to model from left to right so that the green symbol means start point and the blue symbol means end point. So since we have model from left to right, so the start point was more node 1 and the end point was node 2. And we will provide support. So go to general, go to support. Here we will create support first. So click on create. And as we said that we have two pinned supports at the end. So we will create a print support here as well, where the restraints are only the forces in all directions and all the moments are released. Means there will be no moment. Click on add, click on support, assign to view, because we have only two nodes. Okay, yes. As you can see that we have two supports. Now we have modeled the geometry that we have a beam and now we have two supports. After that, we will start assigning property. So since I have explained that we are going to analyze a steel beam. So we will provide the property material of the beam as steel. We have steel here. Click on assign to view. Assign. Okay. So this is the steel section. Now go to property again. And if it is steel, we are aware of the member that is steel. But which section, which beam? Here we have not discussed about any steel section, which section it is. It is a I section, it is a box section, it is a square section, it is a solid or a fluid or hollow or a circular section, it is edge section, it is just a plate or it is just a wire. No, we have not. So let's assume that this is an I section. We will assume that this is a British I section. So go to section database, wait for a few seconds. Go to click on British. In British, select any section. My favorite section is, let's say, in UC, because these are square sections. And let's select UC 203 by 203 by 46. Steel is already selected here. There are different type specification. That is it a single section from table, means a normal section. If you want to select T section only, half from UC 203 by 46, you can select on T. Double profile means two UC 203 by 46 will be stick to each other. Composite section, there are many options. So we will just proceed with single section from table. Click on add. As you can see that the steel section has been added. Now we will apply this property. So use cursor to assign or assign to view. Anything will work here because we have only one beam. So we will use the function use cursor to assign here. As you will click assign, then go and click on the beam. As you can see that the UC 203 46 has been assigned. You can see here as well. When we click Shift plus X, we can see the section size here in the model itself. Now we have provided model. We are able to see the rendered view of our beam, that how it looks. So click on 3D render view in the top, the pyramid symbol, and you will be able to see the rendered view of the beam. So as we can see, this is a 5-meter length I section beam, UC 203 by 46 British section. close this again. We can open it anytime. Now we have provided the section material. We will add some specifications. Since it is a simply supported beam, what we need to do is we need to provide releases at both the ends. When we talk about releases, it will be pinned, means there will be no movement, but there will be restraints with forces in all the directions. So click on beam, and in the releases, click on start, release all the moments, add, then click on again here, location will be end, release all the moments. Okay, so assign the property, assign to view, assign. Okay, as you can see, this blue dot and the end, assign to view. Okay, so we have now assigned the properties of the end specifications. From property, we have already provided the section size, UC203 by 46. Specifications we have provided that it is pinned at both the ends. Support we have already provided pinned supports at both the ends. Loading definition. The loading definition, we need to first create load case. So click on new. Sorry. Click on add, because we are creating a load case within the load case detail folder. So selecting it primary, loading type will be dead load. Because I have just applied a 50 kilonewton dead load here, assume load case 1, add. As we can see, load case 1 has been added. Now click on load case 1, then click add. Now first we will add self-weight load as well. So self-weight load is always downwards, and the factor will be -1, because with y, the global direction of y is upside, and all the dead loads will be acting toward in the negative direction of y, in the opposite direction of y, that's why we will provide -1. Software has already taken it by itself. So just add it here. Now we will go to member load. In the member load, okay, save it. In the member load, we have very different kind of loads. Since we have provided a 50 kilonewton concentrated point load at the center, we will go to concentrated force. In the concentrated force, add -50. If you will provide 50, then the force will be in upward direction. And we are not going to fill any D1 and D2, because if we will leave it, then it will automatically apply the load at the center of the beam. And if it's not at the center, we can provide 2 meter or 3 meter if it is from 2 meter from distance from point A. And the direction will be GY. GY means global Y, as we are seeing here. So add this. Okay, close. Now since we have created the load cases, just we need to apply to our beam. So assign to view, click on self-weight, assign. Okay, yes. Then concentrated load in GY direction, -50 kilonewton. Click on assign to view, assign. Yes. As we can see, we have applied the load. Click on the loads button here. To see the value of the force here in the models, press shift plus V. So as we can see, the direction of the load is 50 downwards, because we have provided minus value, and the value is 50 kilonewton. We have provided the loads, we have provided the self-weight, and we have provided the material as steel. So we are ready, good to proceed with the design. So let's add some things, and what we want to do with this model. So we want to perform the analysis. So click on perform analysis, then click add. Okay. Talking about design, click on design. We are designing the steel member here. So we need to add some design parameters as well. So select parameters, define parameters. Yeah, so in the define parameter section, we are having many parameters available this side. But first thing, you are seeing here that the current code for the design is AISA 36010. But since we have selected the British section, we should select Eurocode 3. So as you can see, we can design our beam based on all these codes, whichever is applicable for steel. So we have EN1193112005 here. So just select the code, then select on define parameters. There are many design parameters. Each and everything is mentioned in EC2, is EC3 design code. So select on beam. We will just add some basic design parameters for the analysis of this beam. So in the beam, select the third option, add. Then let's say add DFF means deflection limit. Allowable deflection, we'll say deflection length maximum. Make it 1. This is the ratio of deflection length by maximum allowable deflection length. Make it maximum 1 and click on ratio. We would like to keep our maximum ratio of applied load to the section capacity as 0.9 only. If the ratio will go beyond 1.9, we will consider that our structure is not good and we should make it more safe. We can make it as 1 also, but keeping some margin with it with our design. If in future, let's say the load has increased, but you have not kept any margin, so it will be useful in future. So let's add the ratio to 0.9. Go to track. On track, select track 2.0, which will help us receive the output detailed results. Add. Then for deflection check results, also add track 4. Okay. Now go to commands, and in commands, click on check code, which will give us the utilization ratio and other design parameters as per the code EC3. Click on add, then click on member takeoff. You would like to just check that what is the total amount of steel, or what is the total amount of concrete, what is the total length of the structures. So we can add other commands as well, but let's leave it for now. So now each one, we have to assign these design parameters to our beam one by one. So click on assign to view, beam 3, assign, press space or enter, DFF, assign to view, assign, okay, ratio, assign to view, assign, track 2, assign to view, assign, track 4, assign to view, assign, then check code, assign to view, assign. Yes. So now let's once before running the software, let's confirm that if we have provided the correct section and the orientation is good or not. Okay, so as we can see, the orientation is good, section is good. We can change the view of our model based on these buttons, and also using your arrow key you can rotate your model very easily. Keeping it back to its original position, pressing on isometric view button. Yes. So now let's analyze the model. Say click on post, go to post processing mode, done. As we have created only one load case, so it's already selected. Click on OK. So we can see that our design is done. And to go through each thing in the design, first in the node section, there is displacement. So if you can see the green line, we are not able to differentiate that how much deflection is it. But in the table, we are able to see that yes, the maximum relative displacement is 14.288 mm at the distance of 2.5 meter, which is at the center of the beam. Because our beam is in 5 meter length, so obviously the maximum displacement will be at the center of the beam. And we can also increase this displacement that you would like to analyze that. So press the control button and scroll the mouse on the upside, and you can see that this is the displacement in our model. So it's just to change the viewing experience to have more visual appeal. It's not like we are increasing the reflection. It's like we are just enhancing our view to understand the reflection of the beam. As we can clearly see, the maximum deflection is at the center, and which is the value is 14.288 mm. Okay, so now go to click on reactions in the node tab only. In the reaction, we can see the vertical reactions are 26.127 and 26.127. So click on the select text. You can just move it little further to have a better view. We can see the y direction is 26.127, 26.127. But there is one catch that in our analysis, the reaction was 25 kilonewton only at each support. So why is this? Because we have not considered the self weight of this beam here. We have just analyzed it as a simple line. We have not assigned any properties, whether it's steel, aluminum, wood, or which section it is. But here in STAAD Pro, we have assigned the self weight. So the software has calculated the length, the total weight of this beam based on length, and it has already included this and calculated the support reactions, including the self weight as well. So this is the best thing, that software do it on its own, and we need not to worry about calculate the self weight of each and every member and other things. So we can see the support reactions are 26.127 kilonewton in the table also and in the model also. Now go to beam. If we go to beam, we can see this is the bending moment diagram. As we can see here, this is the bending moment diagram. The direction of the diagram depends on us, that what we want to consider as negative and positive. So in STAAD Pro, it's negative. The positive bending moment is shown below the line in the negative y direction, and the negative bending moment diagram is shown above y, which is positive y. We can see the values as well. Here, if you click on deflection button, you can see the deflection. Now turning it off, since we have come to beam to see the forces, this is mz, means bending moment in z. We can also see the value of the bending moment, which is maximum at the center, and the value we have achieved is 62.5 kilonewton meter. If you click on results, view value, in beam results, maximum bending and maximum shear. Maximum bending, annotate. Okay, now we can see the maximum bending is 63.909 kilonewton meter. We had the value of 62.5 kilonewton, where we have not included the self weight of the structure. Here we have included the self weight of the structure as well. That's why the bending moment is a little bit higher. If you will click here maximum bending moments, you can see at the distance of 2.5 meter, which is at the center of the beam, the bending moment is 63.909. Similarly, we can see the Fy, shear force. When we click on Fy, it will show the shear force diagram of the structure. What was our shear force diagram? So at the center, since we are doing a finite element analysis of the steel, our diagram in STAAD Pro is little bit different in the center, but it's the correct one. And we can see the values as well. Clicking on results, go to V value, beam results, shear ends. Because in simply supported beam, shear at the ends is maximum. Click on annotate, we can see just value of shear 26.127, this side 26.127. So we have seen the shear force diagram and bending moment diagram of this beam. Now we can also see the stresses. If you create the stress diagram of this beam, so this is the stress diagram. The top one is the 142.083 Newton per mm square stress at the top, and same at the bottom with negative. So in the top it is compressive stress, and at the bottom it's the tensile stress, which we can also see here. The maximum compressive stress is positive, which is 142.083 Newton per mm square, and the maximum tensile stress, which is minus 142.083 Newton per mm square at the bottom. So when we click on the beam, we can see the stress throughout the section of that where is the maximum. So click on the display legend and display corner stress. We can see that the minimum stress means in the negative stress is at bottom in the blue. Here we can see since the load is applied at the center of the beam and at the top. So on the top flange it is the positive and the bottom flange it's the negative. So here also you can see in values. Let's put the distance 2.5. So at the center we can see of the beam here the stress is 0 because it is the center of the profile. And we can also change the what we say the center. We can see 142.0825. See in the table we can see this is the maximum at the center, and the ends it will be less as compared to the center, which is nearly 0. As much as soon you can see here in this diagram, as we are going to the center, the stress is increasing on the flanges of the beam. So the maximum is at the center, which we have seen 2.5 meter, 142, 142. And we can also see within the section as well that at the top flange what is the stress and at the bottom flange what is the stress. So moving the Y point it is in centimeters, and our section is 203 by 46. So its total depth is 203 mm. So and this unit is centimeter. So maximum it will go 10 point something. So putting 10 centimeter, you can see this point is at the top and the value is 139. So 203 divided by 2, it's around 10.15 we can say. So it's around 141.94, around 142. So this is the maximum stress at the top, positive, and similarly, if we'll put minus here, we'll see this point moves here, and we can find this, and we can also move this point anywhere in this direction as well. Just put, let's say 1. See that we can check the stress, local value of stress anywhere around our section, anywhere around the length, and anywhere around the profile section. Speaking of unity check, so unity check is the utilization ratio. That what is the utilization ratio of our beam? Means what is its capacity and what is the load we are providing. So as we can see that our beam is very under design. Uh, the capacity of our beam is too much, but the load is very less. Clicking on graph, we can see the normal 2D diagrams of our beam as well. So the shear force diagram is here, and this is the moment diagram. So we are done with the post-processing of STAAD Pro using a simple and very basic beam design. Talking about report, we can use this button, report setup here. When we click in it, we can select all the information you would like to include in the report. So let's say we would like to include the beam detail, section detail, support detail, basic load cases, material, and loading. And in the output, we would like to include, let's say, no displacement, some because there is no displacement. Let's leave it. We can include beam displacement summary. Okay, beam maximum, beam and forces summary, beam force detail summary, beam maximum moments, beam maximum shear force, reactions, reaction summary, utilization ratio table. That's it. You can also include pictures since we have not taken any picture. We can also include that. So if you would like to have any picture, click on this take picture. So we have taken the one picture and we can take another picture in the rendered view, which will make our report look good. Click on take picture. Okay. Now click on the report setup again. Go to pictures, include both pictures in your, and now we can move whatever the sections you would like to move as per your convenience. We can make our report far better and better, investing more time. Click on OK. Now click here again. Click on print. Once we click on print, select Microsoft Print to PDF, then OK. Let's click on report. Yes. So our report is ready. You can see it here. As we can see, all the details of our beam design is here. Load case, length of the beam is 5 meter. Section property UC203 by 46. What is the area? Moment of inertia, material, section modulus, steel, properties of steel. That what is the properties of steel, density, all other things. What is the load we have provided? We have provided 50 kilonewton load. Then the displacement summary of beam, that here this is the maximum deflection at the center. Then beam end forces are only at the ends, which is 26.127 kilonewton. Beam force detail summary, it is the same. The bending moment at the center, which is 2.5 meters, 63.9. Shear force, there is no torsion. Beam maximum moment, 63. Beam maximum shear force, reaction summary, utilization ratio, and the pictures we have taken. So we have included mostly all the things, and as a preliminary report, we can share it with the one respective authority or a client or contractor for approval. You can fill all the details as well as we have already discussed. So yes, so we are done with the basic tutorial of STAAD Pro, and we can as far as we can, we will go through the each and every functions and each every fixture of the STAAD Pro software. We can be able to build and create some big structures and design analysis of various concrete and steel structures such as buildings, bridges, or anything. So thank you.